Today, we're diving into a world so small, it's almost impossible to even wrap your head around it. But this tiny world holds the power to change pretty much everything. We're talking about nanotechnology, a full-blown revolution happening at the atomic scale.
I mean, really think about that for a second. What if we could build a better world, literally one atom at a time? Not just tweaking things, but completely rebuilding them from the ground up with perfect precision. That is the incredible promise of nanotechnology. And look, this isn't science fiction anymore. This is happening right now. But before we get into all the crazy applications, we gotta understand the scale we're working with.
All right, so let's dive into the nanoscale. I mean, how small is nano, really? Because it's so easy to just hear that word and think, oh, okay, tiny. But the reality is, it's a level of small that's kind of hard to comprehend. Okay, here's our starting point. 1 nanometer. That's 1 times billionth of a meter. Everything, and I mean everything we're about to talk about, happens at this ridiculously tiny level. So, to put that into perspective, right? Grab a sheet of paper. That piece of paper is about 100,000 nanometers thick. 100,000. So, yeah, we're talking about a scale that is just fundamentally unbelievably small.
And here's where it gets really interesting. This is the crucial part. When you shrink a material down to this nanoscale, we're talking somewhere between 1 and 100 nanometers, it just stops behaving like its normal, bigger self. Its properties can change completely. Gold, for example, can appear red or purple. And this happens for 2 big reasons. First, you get these weird quantum effects kicking in. And second, the material suddenly has a massive surface area compared to its volume, which makes it way, way more reactive.
Okay, so we've got a handle on the scale. Now, let's meet the key players in this tiny world. Think of these as the building blocks of the future. First up, you've got the absolute superstar of the nano world, carbon. When you arrange it into things like carbon nanotubes, you get these tiny, tiny cylinders that have unbelievable strength and amazing electrical properties. We're talking perfect for building stronger materials, more efficient electronics, you name it. Then you've got the metals, these little powerhouses. You might have heard of gold nanoparticles. They're so small, they could be used in medicine to spot diseases super early. Or how about quantum dots? Those are the tiny particles making our TV screens pop with incredible color and making solar cells way more efficient. And it's not just about creating new things from scratch. We can also take materials we already use and make them better, like a lot better. You can add things like nanoclays to plastics, and suddenly you have something that's way stronger, more heat-resistant, and lighter. Think about that for car parts or even food packaging. Okay, so we've met the materials. Now for the really cool part. What are we actually doing with them? This is where you see how thinking small is having a huge impact on our lives. Take medicine. The impact here is nothing short of revolutionary. Imagine being able to send nanoparticles directly to cancer cells to deliver drugs, leaving all the healthy cells alone. That's happening. We're using them for advanced imaging to spot diseases way earlier. And yeah, scientists are even working on tiny nanorobots that could one day perform surgery from inside your body. Wild, right? And what about energy? Nanotechnology is right at the heart of the clean energy revolution. We're using nanomaterials to make solar cells absorb more light, boosting their efficiency. They're helping us build batteries that last longer and charge way, way faster. Plus, they're incredible catalysts, which is super important for creating clean fuels, like hydrogen. But it's not just these huge, world-changing things. This tech is showing up in stuff we use every day. Those lightweight composites, they're making cars and planes more fuel efficient. We're getting coatings that make things stronger and last longer. There are even smart fabrics now that can repel stains or protect you from UV rays, all thanks to a little nano magic. And it turns out, thinking small is a great way to solve some of our planet's biggest environmental problems. We can create advanced filters with nanomaterials to get clean drinking water. We can use them as catalysts to literally scrub pollutants out of the air. And in farming, they help us deliver fertilizers with pinpoint accuracy, which means less waste and runoff. So we've seen what these materials are and why they're so amazing. But that leaves a big question, right? How in the world do you actually make something that small? Well, it basically comes down to 2 main strategies. Think of it this way. You can be a sculptor or you can be a builder. The top-down approach is the sculptor. You start with a big chunk of something and just carve away until you've got what you want on the nanoscale. The bottom-up approach is the builder.
You start with the tiniest pieces, individual atoms and molecules, and you build your structure up from there. So let's start with the sculptor's way, the top-down method. This is all about starting big and carving your way down to the nanoscale. A great example of this is something called planetary ball milling. It sounds complex, but the idea is pretty simple. You take your material, put it in a chamber with these really heavy balls, and spin the whole thing like crazy. The force of those balls slamming into the material literally grinds it down into nanoparticles. It's brute force, but it works. It's sculpting on a tiny scale. All right, now let's flip it around and look at the builder's approach. The bottom-up method isn't about smashing things apart. It's about carefully putting them together piece by piece with incredible precision. A really cool example here is called RF sputtering. Basically, inside a vacuum chamber, you use a plasma to knock individual atoms off of a source material. Those atoms then fly across and land on a surface, building up a perfect, super thin film one atomic layer at a time. It's like 3D printing, but with atoms. The precision is just mind-blowing. Okay, so we've covered the scale, the materials, what they can do, and how we make them. So let's bring it all home. What does this tiny revolution actually mean for all of us? The main takeaway here is that nanotechnology isn't just one little field of science. It's more like a foundational key that's unlocking progress everywhere. Seriously, almost every industry you can think of, from medicine to energy to computing, these tiny materials are what's driving the next big wave of innovation. It all comes down to what's written here. These unique properties that only show up at the nanoscale. They're giving us a whole new toolkit, a toolkit we can use to tackle some of our most complex problems, to revolutionize entire industries, and, to just fundamentally improve our quality of life. And that leaves us with a pretty big thought to end on, right? We're gaining the power to literally remake our world from the atoms up. So with that kind of incredible power, the real question isn't just what we can build anymore. It's what should we build first?